Now, what subjective probability estimates do is that they sort of feed into our cognitive biases to take quantification seriously. And so when someone says that the p-doom or the probability of extinction from AI is 15%, we might take it more seriously than we would claims about, the risk of AI going rogue being high.
What's the alternative to reasoning with probabilities? If I don't say, hey, I feel like there's a 50% chance of doom, what am I supposed to do instead? Welcome to Doom Debates. Today I'm reacting to last week's episode of Machine Learning Street Talk with Sayash Kapoor. Sayash is a PhD candidate at Princeton in computer science. He's the co-author of an upcoming book called AI Snake Oil: What Artificial Intelligence Can Do, What It Can't, and How to Tell the Difference. And last week he published a pretty popular blog post on the AI Snake Oil blog, together with co-author Arvind Narayanan. The title was AI Existential Risk Probabilities Are Too Unreliable to Inform Policy. And it caused a bit of an uproar among the doomers because we basically don't like being lectured about not using Bayesian probability. We think that the other side really has it wrong, where Bayesian probabilities are actually incredibly productive and they're kind of foundational to epistemology. So it is actually we who should be schooling you. And this podcast is kind of me expressing that perspective. So let's get into it. We'll take it point by point. Here is the first clip from Sayash.
How seriously should the government take the threat of existential risk from AI?
So the threat of existential risk, I think, is sort of a once-in-a-lifetime event in some sense. And to some extent, I think we've seen policymakers adapt to claims about existential risk, both from prominent AI researchers, but also from communities such as the AI safety community, the effective altruist community. And so to some extent, I think the response is reasonable. It's an event that can only happen once, so we only have one chance to get it right to some extent. And in the article, we try to go over what the arguments for existential risk are and how seriously we should be taking these arguments. And we in particular look at one of these arguments, which is the probability of doom or p-doom, which has become like rampant, not just in the tech community, but also in the policymaking spaces in the last couple of years.
Interesting choice of language to refer to p-doom as an argument, as if this particular issue is being argued by bringing up a probability. It's confusing to me to approach it that way because every issue should be argued by referring to probabilities, right? So why is he surprised that this particular issue is being discussed using probabilities, as if probabilities are like a tool that's specific to this issue? And if you listen to how he frames it, he's saying like, oh, there's all these different arguments, but one of the arguments is p-doom. Okay, weird way to begin, but let's continue.
So you made the argument essentially that these risk probabilities are too unreliable to inform policy. Can you elaborate on that?
Yes. So when we're coming up with probabilities for any event, I think there are basically only three ways to go about it. We can come about it inductively. That is, we look at past events of a similar sort that have happened. We can come about it deductively. That is, we have a theory for how the world works, and then we apply the theory to make predictions. Or, as has become the norm in the AI community, we can come about it subjectively.
Wait, what? We use Bayesian reasoning. Bayesian reasoning means that you have a bunch of different hypotheses about how reality works, and they all have a probability, and then evidence comes in, and you update the probabilities of your different hypotheses, and at any given time, somebody can ask, hey, what's the probability of this hypothesis? And you can tell them, because you're always keeping them updated. Like, this is how Bayesian reasoning works. According to many mathematical theorems, this is just how intelligent agents have to operate. To the extent that it looks like they're operating using some other framework, that framework will only work if it's equivalent to Bayesian reasoning. Sayash is just bulldozing right past the methodology of Bayesian reasoning, as if this is like a fresh idea for him. Like, how does one use probabilities? Does one just make a sequence of events in the past and try to pattern match that sequence? No. Bayesian reasoning is a thing. It has a ton of credibility. Like, how do you just dismiss it so early in your talk? I don't get it.
Now, let's set that one aside for the moment, and let's dive into inductive and deductive probabilities first. So in terms of inductive probability, you can come up with great probability estimates for the risk of, let's say, car crashes by looking at like a person of a certain type who drives a certain type of car, lives in a certain neighborhood, etc. Insurance companies regularly price products like car insurance premiums. And I think more or less that seems to work well. I mean, there are some nuances about bias and risks of discrimination. But apart from that, like let's say if car insurance prediction is 20% off, that seems all right, right? We cannot do that for AI risk simply because there is no past evidence for this type of work. We don't have a reference class, so to say. And so any probability numbers that we come up with based on past events are extremely speculative. Now, to be clear, this reference class is a spectrum. So certain things can happen multiple times, many millions of times, and we have extremely precise reference classes, if you will. So like when you toss a coin, we have a very clear reference class, and we can predict that the probability of a fair coin will be, let's say, 50% landing as heads and 50% tails.
This is a common type of argument that non-Bayesian makes. They're saying, look at the gold standard of probability. The gold standard is basically frequentism, if you're familiar with that term. It's when you can just look at an event that's happened before a bunch of times, and you can use a very natural similarity metric, like, hey, I flipped this coin 1,000 times, and so the next coin flip is surely in the same reference class as the previous 1,000 coin flips. So this is the gold standard of probability. If it came up heads 500 out of 1,000 times and I'm going to flip it again, I'm totally justified in saying that I have a 50% chance of having the next flip be a heads and a 50% chance of having the next flip be a tails. But wait a minute. If we're talking about epistemology, what gives us the right to know things, what gives us the right to make sound predictions about the future, it's not like this kind of frequentist attitude really is the gold standard. There's the famous example that Nassim Taleb talks about the turkey. Right? The turkey who's going to get slaughtered for Thanksgiving. Well, every day, 365 days in a row, the turkey gets fed breakfast, lunch, and dinner. The farmer wants the turkey to grow nice and fat. Thanksgiving comes along, the turkey gets slaughtered. But wait, I thought the probability of getting slaughtered was 0 out of 365. I just got fed every day for a year, right? So what do frequentists say about that? Is that the epistemological gold standard, to just find a sequence and then just use the ratio of that sequence? No, it's absolutely just a shortcut. Frequentism is just a shortcut. When Bayesianism gets into a certain groove, into a certain pattern, Bayesianism might license a frequentist approach. Bayesianism might say, don't worry, I don't have a model that you're part of a farm. My model really is that you're finding your own food, that your food source is stable, and so go ahead and use this reference class of how many times you've been fed. Without that larger perspective, without actually building a model, a gears level model of what's happening in your universe, you can't just expect to extrapolate the pattern and always be robust, right? So I just wanted to undermine that kind of claim in general, like it's the gold standard of the epistemology of probability when you can put together a sequence of events. Now, you might think Thanksgiving turkey is a contrived example. I don't agree. There's all kinds of examples where naive frequentism is going to fail. Look at the stock market. A lot of people get the idea that they have a winning strategy in the stock market when what they're really doing is picking up pennies in front of a steamroller. So every day they might sell a call option, and the call option pays them a penny in profits. But the downside is that if the market were to ever crash beyond a certain range that they're not expecting, suddenly they're on the hook for like $100. So it's like every day it's like, oh, nice, I picked up a penny. I picked up a penny on this call option. This call option is great. It's just printing money a little bit every day. And then like 2 years pass, and then suddenly one day you're on the hook for $100. And it wipes out all of those penny gains that you made over the entire last 2 years. And that's how people lose in the stock market, because they get comfortable. They're like, oh, I know what I'm doing. And then what Nassim Taleb might call a black swan wipes them out, right? Something that undoes all of those things that they thought were so stable. So that's just another example of when naive frequentism, being like, look, I have a pattern of making money. It's just another example of when naive frequentism is going to fail you.
We might have reference classes that are somewhat more vague, like the car insurance example. And then in typical probability estimation of events, the extreme end of the spectrum is things like geopolitical events, where you have the risk of war, and the reference class is past events of a similar nature. So past wars that have broken out, past famines that have led to political instability, and so on. Now, compared to this entire spectrum of reference classes, AI risk is maybe completely outside the spectrum, or at like an extreme end of the spectrum, to the extent that a reference class just does not exist. Now, people have tried to come up with reference classes, and I'll share some of them just to show how absurd these reference classes can be. One example is the risk of various animals going extinct. Another reference class is past sort of changes to the Earth's atmosphere, past waves of extinction that we've seen. And hopefully it's clear how very different all of these types of risks are compared to the risk of us losing control over AI or power-seeking behavior emerging in superintelligent systems or all of the other hypotheses.
Just to repeat what he's saying, if I were to ask you to predict whether war is going to break out between Israel and Iran, or North Korea and South Korea, or India and Pakistan, well, you could pick a natural reference class of previous instances of political instability, or you could compare it to previous wars that have broken out, and you could try to set up a fraction with a numerator and denominator of like, okay, the times that things felt tense, war broke out with this frequency. And in his mind, that's pretty justified to do that, to set up that particular frequentist ratio. But he thinks that that's totally different from what you could do with existential risk, where if somebody asks, hey, what's P doom from AI? Well, comparing that to the reference class of times on Earth when species have gone extinct, he just thinks that's crazy. That is not a good choice of reference class, because the similarity metric that he's intuitively using, for him, it's just not that similar to look at other extinction risks throughout history to other types of species. That's not similar, but if you're looking at this new war breakout event that you're predicting, well, that is similar to previous war breakout events. And of course, the devil is in the details of what exactly you're going to use for the numerator and denominator in that frequentist fraction. I think it's really not frequentism, because it is open to a ton of judgment what you're going to use in the numerator and denominator. And the numbers could come out very differently depending on the way you actually implement what you think is an obvious reference class. So I think he's already on very shaky ground here, making the point he's trying to make. I guess I will concede that, like, okay, I guess it's a little more similar, war between humans compared to war between humans, versus, you know, a human extinction from AI compared to like the dodo going extinct, or like a super volcano making 98% of species go extinct. Like, I guess that's slightly more similar, but it's just Bayesian reasoning. The way that proper intelligences reason about the universe doesn't depend on these qualitative, subjective similarity metrics and then setting up these naive fractions. That's not how you reason when you want to actually get results, right? That's already a very oversimplified, bad explanation of how to put probabilities of things. But like, I can see that if I were a frequentist and I thought that this whole framework made sense, then okay, I see what he's getting at. But I think it's a terrible framework.
So it is on this basis that we reject the idea that we can come up with reference classes, and therefore we can come up with inductive probability estimates of the risks of AI doom. So that leaves us with deductive estimates of probability. Deductive estimates are those where we have a theory that we have validated in some real-world setting, and we seek to apply it to this other real-world setting. And we have faith in the theory simply because of it being validated and us making assumptions about the scope of this theory.
He's using this term, deductive estimates of probability. That's non-standard language when we talk about epistemology. Like, how do people know things? How do they shift their beliefs so that those beliefs have a high chance of being accurate? How do humans do it? How are we going to program AIs to effectively do it? How does cognitive work yield results? Right? We're talking epistemology here, and it doesn't seem to be a strong suit, because that description that he just gave is quite clumsy. His description is, deductive estimates are those where we have a theory that we have validated in some real-world setting, and we seek to apply it to this other real-world setting, and we have faith in the theory simply because of it being validated and us making assumptions about the scope of this theory. Okay, if you want to describe how people know things, it's because we come up with hypotheses that compress the data that we get. The hypothesis is validated by the fact that all of the data that we get has a much more compact representation when somebody has that hypothesis. And as long as the compressed hypothesis actually matches the data makes the hypothesis accurate, then that hypothesis gets a higher evidential weight. It gets multiplied by an odds ratio, and then you also have to consider your a priori probability, how likely you thought the hypothesis was before you got this new information. But that's kind of a detail in Bayesianism, because once you get enough evidence, it's just going to be clear which hypothesis compresses the data the best, and it doesn't really matter what your a priori beliefs were, because they get overshadowed by this huge likelihood ratio that your hypothesis has earned. So anyway, right off the bat, I'm just noticing that Sayash is just not explaining how cognitive work makes your brain correspond to reality. Your brain is an engine where data comes in and it says which of the different things I know are the best explanation in a formal quantitative sense, the sense of compression. When scientists are creating theories, when Einstein is creating his general relativity, he knew it was accurate because it was a compact theory that fit a bunch of paradoxes about how the speed of light can be constant in every reference frame in every direction. Once Einstein hit on that theory, he already knew that it had a very high probability of being true just because of the ratio of how few bits it took to describe what he found and how many known cases it applied to that didn't have alternative explanations. So Einstein was already very far down the path of validating his theory. I disagree with this language that Sayash is using when he says, us making assumptions about the scope of this theory. We don't have to make assumptions. There's actually a formal procedure that makes your theory get validated. And the formal procedure is if you have evidence that is compressed, the description of all the evidence you're getting is compressed by the theory that you have effectively and accurately, then your theory deserves a lot of Bayes points. You deserve to update toward a high probability of having that theory. So ultimately, all I'm doing is I'm just pointing out that there's this framework of how people have accurate beliefs, and Sayash is kind of giving this ad hoc version that doesn't explain it very well, which is a red flag for what he's going to say next.
Now, this is all a little bit abstract, so let's get concrete. One example of X risk that's not from AI is existential risks from asteroid impact. So we might be concerned that when an asteroid of a sufficiently large size, let's say, collides with the Earth, there would be enough energy generated that it could sort of clog up the atmosphere and block off all agricultural production. Now, how can we come up with a deductive theory for this? Well, we have evidence from a large number of smaller asteroid hits as to what happens when an asteroid collides with the Earth. And based on this theory, we can sort of extrapolate to what would happen when a large enough asteroid hits the Earth. And again, I'm drawing from other theory about what would happen and how much energy would be needed to sort of block off the production of agriculture in the world. We can then come up with an estimate for how big an asteroid needs to be and how often these big asteroids do flybys close to the Earth to see what the probability estimates of or the p-doom of asteroid impact is.
I want to nitpick the relationship between observing what a small asteroid does and predicting what a large asteroid would do, because just reading back what Sayash said, he said, we have evidence from a large number of smaller asteroid hits as to what happens when an asteroid collides with the Earth, and based on this theory, we can sort of extrapolate to what would happen when a large asteroid hits the Earth. I don't know if he misspoke and he's just talking about the probability of those events, but if he's literally talking about predicting what's going to happen when a large asteroid hits the Earth by extrapolating, that's not necessarily true, right? The physical consequences of an event don't necessarily scale linearly. For example, we can just have lots of small asteroids hit the Earth and be fine, but then when a sufficiently large one hits the Earth, we won't be fine because there's nonlinear effects, right? There's thresholds where it's like, oh, this one blocked the atmosphere, it didn't just kick up some dust, it blocked out the sun, right? Things like that. But anyway, I think the more important part of what he said is when he talks about predicting how often these big asteroids do flybys close to the Earth and using that to see what the probability estimates and the p-doom of the asteroid impact is. So yeah, the frequency of when big asteroids come, I mean, maybe we can extrapolate some trend in the data, like, hey, some small asteroids come, some bigger asteroids come, maybe some bigger one, maybe you'll get like a power law distribution or something might just fit really neatly into some mathematical distribution. And so that hypothesis might be the best thing you've got compressing the data. Of course, that's not even true, right? I mean, Newtonian mechanics, forget general relativity, just the idea of like, hey, gravity makes things fly around using certain forces. And so these are the kinds of patterns you can expect. And if you zoom out and you look at the whole galaxy, you might expect this. I would not feel at ease just looking at a power law of all the different asteroids that we've seen fly by the Earth. I would really want to understand what makes stuff fly around, because I would really want to understand, like, hey, what are the chances that something from a nearby galaxy that's just not on our radar at all, looking at the historical data, what are the chances that some other force is about to come down on us, right? I wouldn't just use naive frequentism. I'd be like, what's going on in the universe? How do these things work? Is it possible to get any confidence that things that have never happened before will still not happen for some actual reason instead of just drawing a graph? Right? That would make me a lot more confident. And luckily, we do have some results like that. For example, the speed of light limit tells me that if I look around to the outer reaches of what we can see and I don't see any threat coming, then that means I probably actually am safe for like a few billion years, right? Because I'll probably start to see threats coming before they can suddenly appear on my radar, right? So there's things like that where you can use actual understandings of stuff to help shape your probabilities. Now, in the specific case of asteroids, I mean, we have the Chicxulub impact crater of the asteroid that killed the dinosaurs, and that would probably kill humanity too, leaving only, well, it would kill a large fraction of humanity, probably leaving a few survivors in caves. But anyway, like an asteroid like that or bigger is indeed like a very big threat. So is this a success case for frequentism? Yeah, I guess, right? I mean, there's like a standard estimate that like, yeah, in 100 million years or so, we're going to expect another species killing asteroid. And like that is in fact an existential risk. It's easy to predict. And you don't see a lot of asteroid doomers raising the alarm, acting like a really big asteroid is going to come in the next 100 years, right? Like nobody's saying that because we all agree that this is a case where like, yep, the universe just slings around these asteroids and they all have these predictable trajectories, and there's no particular reason to expect something to come in 100 years rather than 100 million years. So it's precisely because we understand that asteroids are simple and they just follow simple mechanics that you can model as Newtonian effectively. It's because we know that we're then comfortable just using frequentist statistics. So I don't have a major disagreement with what he's saying. I just wanted to point out that one nitpick.
We have no such theories for existential risk. People have tried to come up with theories. One theory is that, once the number of computations in an AI system equal the number of computations in the human brain, that's when we'll have transformative AGI. But that tells us nothing about whether this AI is likely to lead us to sort of the lack of control scenarios that are talked about.
This strikes me as perhaps not a logical non sequitur, but certainly a very sloppy way to unfold his argument. He starts by saying, hey, we don't have a theory of superintelligent AI extincting humanity. I mean, we may have a theory, but we don't have a theory that has this giant set of data like asteroid trajectories that can make us feel confident drawing a graph and at least checking out that if the patterns hold, then we're good. We just don't have that level of quantitative data that everybody agrees on is a totally relevant pattern to extrapolate. So that's fair, right? And a lot of theories are just like one-offs like that, right? Like the theory that says, hey, eukaryotic cells have mitochondria because at one point the mitochondrion was an independent organism and then they merged. Well, we don't have a bunch of data points proving that, right? It's just like a really plausible theory that has like a bunch of strong arguments and most people agree it's true. And you can keep arguing for it, but you're not going to get like a bunch of data points of like repeatable events because it probably happened once in evolutionary history. It was like a pivotal thing that happened. So the part where he says, hey, we have no such theories for existential risk, he's correct that it's not one of those super quantitative extrapolations like, hey, an asteroid is going to kill us in 100 million years because of this data. Which I'll agree, but that's true of many great theories, right? Like the theory of mitochondria endosymbiosis. That's like a very important theory in biology, and it also doesn't have a similar graph you can draw, and plenty of theories are like that. Now, the red flag for me is what he said next, where he started getting into the theory that some people have. I don't have that theory, but I guess Ray Kurzweil has that theory when he mentions the number of computations in an AI system equals the number of computations in the human brain. That's when we'll have transformative AI. Again, it's not my claim, but the fact that he dives into that claim as if that's a load-bearing claim of the AI doomer claim, that's not how the AI doom claim is structured. The AI doom claim is a conditional claim that once we have superintelligent AI, then it'll be uncontrollable and then it'll cause extinction. So the fact that he's already getting into the weeds about some particular person, Ray Kurzweil, some particular person's claim about when we're going to get super intelligent AI, he's just being sloppy in how he's structuring his argument. And I may be nitpicking, but I feel like I'm going to be nitpicking him a lot because I feel like his whole argument against doomers is accusing us of being sloppy. So I do want to point out anytime I see him as being quite sloppy because ironically, I think he's guilty of what he's accusing me of.
But more importantly, this assumption itself is extremely tenuous. We don't understand as well right now whether this is precisely what leads to intelligence, whether there are other factors. In fact, I would say many neuroscientists would vehemently disagree with the fact that the number of computations is what leads to intelligence.
Again, that's not part of the doomer claim, to the point where it's kind of a non sequitur that he brought it up this early in the conversation. Like, make your actual argument, please.
And now this brings us to sort of the final part, the part that I set aside for the moment. So lacking either inductive theories, so a reference class for making inductive probability estimates, or deductive theories about how AI risk might come about, what the community has largely turned to when forecasting the risk of AI extinction are subjective probability estimates.
I disagree that I don't have a quote unquote deductive theory of how AI existential risk might come about. So, intelligence studies is a real field of study. When a Go engine is able to beat you at Go, we can say that it's more intelligent than you are over the domain of Go. When it can beat you at a math Olympiad, it's more intelligent than you with respect to that math Olympiad. You can try to shrug it off and say, no, it's just doing this trick, but it doesn't matter what that trick is doing because the definition of intelligence is actually relative to the problem being solved. So anything that's capable of solving a particular problem in a particular domain is intelligent with respect to the domain. So anyway, I'm just explaining a deductive theory. A deductive theory is saying, hey, an engine that can beat you in this domain, you'll be powerless in that domain, right? So if you build a better chess engine than you and you were hoping to determine what the end state of the chess game board was going to be, my deductive theory tells you that you're not going to be able to do that. You're going to have a loss of control with respect to chess if you build an AI that's better than you at playing chess. And the shape of the doom claim in the physical universe, it's very straightforward deductive logic to say, hey, if it's better than us at optimizing the physical universe, then you're going to experience a loss of control in the physical universe. So that part is quite deductive. And then it largely comes down to asking, well, are such engines going to be built? Is superintelligence a thing that can exist in the universe? Or are things always going to be kind of close to human intelligence? So you can ask that question. But to accuse my model of not being deductive while you go ahead and you let the theory of evolution or the theory of endosymbiosis or the Big Bang Theory or the theory of evolutionary psychology, all of these other theories I'm naming are perfectly well-justified theories, even though it's not obvious which pretty graph justifies them. It's not obvious what the numerator and the denominator are in setting their probabilities of being true, because the world doesn't factor into these frequentist patterns that you apparently think that it does. So the fact that you're not going after all these other highly justified theory and you're singling out the theory of intelligence and the argument for AI doom as if we somehow have bad epistemology, that's your arguments to make. Because I personally think that I have good epistemology. I'm explaining my epistemology, and you're coming out with sloppy arguments that are intended to prove that I have bad epistemology. And when you say the community has turned to subjective probability estimates, it's almost always quote unquote subjective probability estimates. If you want to go purchase a business like Warren Buffett would, and you want to find the fair value of the business using the formula for discounted cash flow, well, that formula, every variable in that formula is going to be subjective. If you want to do GAAP accounting, every variable in accounting is subjective. If you want to be a super forecaster and forecast anything, unless it's the trajectory of an orbit that you can predict very precisely, right, or a quantum experiment that we have to many digits of precision, usually you have all this math, you have all these formulas, but the variables in the formula have a little bit of subjectivity. And what the subjectivity means is you take the full complexity of the human brain, which has a subtle model about the universe that's more subtle than what we can explicitly describe, and an AI could have the same thing, but with a higher ability to explicitly dump it out. But anyway, you take all that subtlety and you use it to tweak your subjective estimates. But anyway, this idea that making predictions based on strong models is going to have subjectivity, that is standard. So I really resent how he's singling out doomers and being like, oh, wow, these guys are turning to subjective probability. Yeah, it's called Bayesian probability. That's how the world works. And look around, okay? Because I feel targeted.
Now, what subjective probability estimates do is that they sort of feed into our cognitive biases to take quantification seriously. So I think all of us have many cognitive biases. Quantification bias is the tendency to take events that are quantified more seriously than ones that aren't. And so when someone says that the p-doom or the probability of extinction from AI is 15%, we might take it more seriously than we would claims about, the risk of AI going rogue being high.
I've never seen a single AI doomer try to exploit quantification bias by using more digits of precision than they have. I personally say that my p-doom is 50%. That's not 50.00000%, right? How many significant figures are in that probability? Less than 1. When I say 50, I really mean what Jan Leike, formerly of OpenAI, famously said. Formerly, he was their head of AI safety. He said 10 to 90%, right? Is it really 10? Is it really 90? Is it really 50? It doesn't matter. What matters is that if you say it's only 3%, that's clearly a crazy bad probability to give because it's too low. And if you say it's 97%, you're also probably not thinking straight. It's too high. So I can tell you with high confidence that it's ridiculous to call it 3% or 97%. If you call it 60%, I think that's fine. If you call it 70%, I think that's fine. If you call it 12%, I think that's fine, although I think you have too much precision, right? So that's what I say when I say p-doom is 50%. A lot of people are very quick to laugh that off, and they're like, oh my God, Liron's saying nothing. No, I'm not saying nothing. 50%, specifically, one thing that it means it's definitely not 0.01%, right? So can I tell you if it's 50% or 40%? It doesn't matter. I could easily shift between that on any given day. But would I ever tell you it's 0.01%? No, 0.01% is crazy. So I'm telling you something meaningful when I'm eliminating the range of low probabilities. If somebody's making decisions as if p-doom is super low or super high, then I claim that they're blind to this obvious synthesis of the facts we know about reality. The facts we know about reality tell us that doom is a very salient danger, right? So now I'm just using English. I'm saying very salient. But instead of saying very salient, I can tell you, hey, something in the 10 to 90% range, just like Jan Leike of OpenAI did. I think it's very presumptive of Sayash to be like, oh yeah, Jan Leike of OpenAI is like trying to fool you. He has bad epistemology because he's using probabilities. It's like, no, he is doing a great job when he says 10 to 90%, because just to reiterate, he's pointing out that somebody who comes out saying 1% probably doesn't have their head screwed on straight. And that's a very meaningful statement that does not draw on quantification bias. If anything, the idea that somebody would come in and claim, hey, p-doom has a 0.1% probability. Who's the person drawing on quantification bias right now? Is it the one like me or Jan Leike who's saying 10 to 90%? Or is it the one who's saying doom is so unlikely it's 0.1%? 0.1%, that's a 999 to 1 odds ratio, right? That's like my $1 for your $999. Your $999 says that we're not doomed. Who's the one who's trying to draw on quantification bias in that scenario? I don't think it's me, right? So I think Sayash is just way off base here, accusing doomers of trying to use quantification bias to their advantage.
If we look at all of the evidence that the community making predictions about AI doom have given us, the underlying reasons for these probability estimates are extremely tenuous. So one of the most important, I believe, prediction tournaments that happened recently was the Extinction prediction tournament. It was carried out by Philip Tetlock and his colleagues, and they basically asked, I think, 100 or so AI researchers, as well as super forecasters, that is, people who had excellent records at forecasting events in the past, to participate in a prediction tournament, that is, to predict the possibility of X risk. And it turns out that if you look at the reasons that people gave to justify their abilities, those reasons are no better than what we might expect from anyone like on the street who is thinking about AI risk. Reasons included things like, well, maybe AGI would decide to colonize space instead of the Earth, and so they'll reduce their AI doom risk, and so on.
That's a terrible reason. So whoever said that is just not educated in the theory of AI doom, right? Because it's a pretty significant minority of AI doomers who would tell you that AI doesn't want to colonize the Earth before it colonizes space, right? I mean, that's just almost certainly wrong, right? So if a super forecaster really thinks that, it seems like they've taken some license with not studying AI doom theory. And I don't see how that's excusable when you're trying to forecast how AI doom is going to play out, to not actually understand why it's so important for an intelligence to use the resources on Earth before spreading to space. Like, those resources are right here.
And so what we really take issue with is dressing up these feelings as numbers and making it seem as if there is a precise estimate behind claims that there is a high risk of extinction from AI.
So again, nobody's claiming precision, right? So you're accusing AI doomers of being precise. You can look on the record. I mean, again, let me give you exact quotes. Jan Leike, 10 to 90%. Dario Amodei, 10 to 25%. Jeffrey Hinton, I think it's more than 50%, but based on what my friends are saying, I've updated down to 10 to 20%. None of these three statements from some of the top luminaries in the field are trying to use false precision, correct? Again, the person who says, I'm so convinced that AI doom is fake, that we should treat it like it has a 0.1% probability, whose probability is more precise? There's actually no way to have a very, very low probability of AI doom without that probability being precise. Because you could be like, oh yeah, just really, really low, just like below 0.1%. It's like, wait a minute, below 0.1%, so bigger odds than 999 to 1? And again, who's the one being precise? You're kind of projecting here.
So your article argues that there are many reasons why these risk estimates might be, systematically inflated. I mean, can you tell us about some of those reasons?
Absolutely. So when we look at the metrics that are used to evaluate these forecasters, we find that they severely overestimate the probability that events that might not ever happen or might happen very infrequently, also known as tail risks, in a systematic fashion. So in the blog post, we do an analysis of one such example. So let's say we have two forecasters, forecaster 1 and forecaster 2. Forecaster 1 always makes the correct probability estimate based on their prior. Forecaster 2 makes the exact same estimate, except if the risk is less than 1%, they always predict the risk to be 1%.
So the relevance of this statement is presumably supposed to be that doomers like me go around taking a tail risk and acting like it has a 1% or more probability, when the real probability should be like 0.0001%. But it's just so easy to round up those tail risks and overinflate those tail risks. So that's the crux of the issue then. Is AI doom a tail risk? Is it just like some unexpected event that might happen if we're unlucky? Or is it more of a mainline risk, right? Are we just heading toward AI doom? And in my view, it's mainline, because creating a superintelligence without knowing how to control it doesn't lead to a good outcome, right? That's my mainline risk. That already suggests a ballpark 10 to 90% type of probability, which is why actual industry experts are largely agreeing with that estimate, right? And brushing it off by pointing out that super forecasters overestimate tail risks, I don't see how that's relevant to a situation where the experts, the doomer experts, are just arguing that this isn't even a tail risk. So why are we talking about tail risks?
You mentioned the dangers of utility maximization when it comes to X risks. How should policymakers approach this problem without falling trapped to Pascal's wager? And if you wouldn't mind, could you explain what Pascal's wager is?
Absolutely. So Pascal's wager is this very interesting thought experiment about whether one should believe in God. So it states that one should always believe in God, because if it turns out that God does indeed exist and one does not believe in God, there's an essentially infinitely negative utility function to that call, because it's like an infinite life in hell. Whereas, so if there's even a small possibility that God exists, one should always believe in God. So this is an example of the dangers of utilitarianism in dealing with making consequential decisions. Because let's take the example of X risk. What if we try to estimate the utility, the expected utility of existential risk, even if we have a very low probability? Now, some of us, and like reasonable people, might conclude that the cost of humanity going extinct is essentially infinite. There's probably nothing worse that could happen. And therefore, if you have even a very small probability that is non-zero that humanity goes extinct, you're incentivized to always do everything in your power to stop existential risk. So if we were to take this seriously, if we were to adopt a purely utilitarian expectation maximization theory and apply it to real world decisions, all policymakers would ever do at any given point of time is talk about X risk.
I'm sorry, at this point, anybody who ever brings up Pascal's wager as if it's relevant to the debate around AI doom should be embarrassed. We're past that for the simple reason that doomers don't argue a low probability. Doomers argue generally a probability of 10% plus, at least 5% plus. And what characterizes a Pascal's wager scenario isn't just that it's dealing with high utilities, it's that it's dealing with small probabilities. The point of invoking Pascal's wager, of saying, oh my God, look at this huge utility, the point of doing that is to compensate for a tiny probability. So if I were to say, hey, look, I know that AI doom is only 0.1% chance, but it's so important to solve AI doom because the consequences are so large. If that's what I was saying, then you could accuse me of arguing for Pascal's wager, trying to distract you and have you focus on the high utilities so that you can neglect the small probabilities. But as I keep repeating, nobody on the doom side is saying that the probability is that low. We're generally saying 10 to 90%. That's kind of where the doomers are. Let's say 5 to 95% to have kind of a big tent, right? 5 to 90%. Again, you might think I'm crazy for saying 5 to 95%. I don't think I'm crazy because I'm ruling out the sub 5% area where Pascal's wager is even relevant, right? Why are you talking to me about Pascal's wager when I'm telling you that the p-doom is more than 5% or more than 10%? I'm giving you such a high p-doom that even if the utility consequences, even if a mere $1 trillion were at stake, and not the fate of humanity's entire intergalactic future, but just a mere $1 trillion, even then you'd want to pay attention to me when I'm talking about a 5% risk of burning a trillion dollars, or 10 trillion, whatever, some earthly number as opposed to some crazy astronomical number, just an earthly number, right? The probability is already so high, 10%, whatever it is, it's already so salient that even an earthly number like 1 trillion should already get you out of bed. So why are we talking about Pascal's wager? Why is somebody criticizing doomers and using that keyword Pascal's wager? Frankly, I should never hear that keyword anymore. It's not relevant to the doom debate. If we were talking maybe 50 years ago and somebody was saying the probability that we're going to have uncontrollable AI in the next decade, maybe the probabilities would get small then. But if you talk to doomers today, we're not throwing around 1% probabilities. We're all at the 5%, 10%, 50%, 90% level. Okay, so get with the program. Don't say Pascal's wager. The one thing I'll say is you didn't say Pascal's mugging. There's this thing called Pascal's mugging, which is an even more extreme version of Pascal's wager that we don't have to get into. But accusing doomers of Pascal's mugging is like an even dumber version of accusing doomers of Pascal's wager. I hope to never hear it again. I suspect I will because I've already heard it from multiple smart people. But please, study up. Don't accuse doomers of Pascal's wager. It's just an objectively wrong accusation of what we're claiming.
How do scaling laws compare to other scaling plateaus, like airplane speeds, for example?
So there's a strong tendency in the field of AI, in some parts of the field of AI, but more broadly in the field of people talking about AI, to assume that exponential trends can hold indefinitely. I think very recently I read this piece called Situational Awareness that draws these trend lines that go all the way up to the right and argues on this basis that we'll get to AGI sometime very soon. Now, our piece on AI scaling myths was not a direct response to the situational awareness piece. A lot of people thought it was, but we'd actually been working on it for a little bit of time. But essentially, if we look back at the history of what happens to things that people have thought are exponentials, what happens when we sort of look past, let's say, the first few years of this type of exponential, we've found that people have largely been disappointed. I think there's a saying that goes, every exponential is a sigmoid looking backwards. And so this is exactly what happened with airplane speeds. I think in the early 1970s or late 1960s, people were booking flights to the moon based on the increasing trend of airplane speeds at the time. And then essentially all of a sudden, these increasing airplane speeds came to a halt.
But I thought they were using a good reference class. I thought they were looking at the data and using a frequentist probability estimate. I guess that's not a reliable methodology, huh? I guess we need to actually understand things and make predictions based on deep theories.
We had these saturated around the speeds that we have today. And the reasons for that were a little bit technical, a little bit business related, but essentially it shows the perils of thinking that trend lines can continue forever. I think there are always bottlenecks that arise when previous bottlenecks are fixed. And that's how we've also seen progress in AI. If we go back, 50 years, in the last 50 years, we see that AI progress has been a punctuated equilibrium. So every time we have a new paradigm, there's a lot of resources, a lot of intellectual as well as material resources that are spent in improving this paradigm. And this is how progress takes place until we've saturated a paradigm. And once we saturate a paradigm, there is essentially a period where we're looking for the next paradigm, and progress sort of slows down. It becomes the sigmoid, not the exponential anymore.
So I actually do agree on an important point, which is I don't take the Kurzweil perspective of let's just extrapolate Moore's law. Let's naively extrapolate a trend to get to a prediction about when we're going to have superintelligence. My position is, we're pretty clueless about when superintelligence is coming. I generally estimate it to be 1 to 30 years away. The reason I'd be surprised if it's more than 30 years is something I've said in the past where it's just it's getting hard for me to name what it can't do. I've always had these convenient bounds of things I could tell you AI couldn't do. Hey, it sucks at chatting, right? It can't even write me an essay. It doesn't understand English. Whereas now it's okay, it kind of understands everything, but it starts being bad at it once it says more than a few sentences, but the next version is going to get you an extra sentence. It's starting to get hard for me to draw a boundary about what the AI can and can't do. And so that's why I get the intuitive sense of I don't really know what else is left besides just reflecting back on what it's doing. Like it's hard to explain, right? And so that's why I'm saying it's hard to imagine that 30 years from now we still won't have cracked it. But I certainly give that a significant chance, right? I'm not claiming to be like, we're doomed because I'm extrapolating this graph. No, that's not my claim. My claim is just, I think that we'll have super intelligent AI eventually. If we don't get it in a year or a decade, I'm quite sure we'll get it in a century, right? More likely than not. I think that's a pretty mainstream position. My doom claim is just, if and when we get superintelligence, probably when, not if, at that point, unless we know how to control it much better than we know today, we don't have a clue, unless we know how to control it, then we're doomed because it's going to make humanity lose control. It's just going to strip us from our causal influence over the future, and it's just going to have all the causal influence. The same way that a chess AI has all the causal influence over the winning configuration of the chessboard. Similar dynamic. That's my whole doom claim, okay? So I do think that we're getting sidetracked talking about, naively extrapolating trends. Fine, you're right. I don't want to naively extrapolate trends. Okay, so the interview with Sayash goes on for like another half hour, but this is the end of where he talks about his claims that doomers are like misusing probabilities or making claims that are somehow not epistemologically sound. The title of Sayash's blog post that he was being interviewed about is AI existential risk probabilities are too unreliable to inform policy, which of course I disagree about because when you have half the experts in the field warning you urgently that in the next 1 to 30 years, the entire human race is going to go extinct and their probability estimates that they're putting on it is in the 10 to 90% range, even without much precision, I do think that you want to start shaping policy around that as opposed to being like, let's just not shape policy around that. I think that it would be more prudent to shape policy around that. So I'm not moved at all by what he's saying on an epistemological level. And as you saw, I had my nitpicks. Like, it just doesn't seem like he's getting how epistemology works, what a well-supported theory looks like, even if it doesn't have a pattern of statistical data supporting it. Or conversely, I didn't even mention the case where you might have a theory that has a bunch of data supporting it, and naively you just extrapolate the data and be like, wow, surely this theory is true. For example, I could give you a ton of data showing that Newtonian physics is just correct. It's an accurate description of the universe. And for a century or two, people just thought Newtonian physics was correct. But then they just started seeing some cracks like, oh, wait a minute, this could be self-contradictory when we're dealing with fast-moving charged particles, or wait a minute, this contradicts observations of the planets a little bit. There's like some inaccuracy here. But before the cracks started showing, you might have had people be like, you know what, this is 99.999% likely to be true because I have like 100,000 data points of all types. The data points are all fitting. And so I have a lot of confidence that Newtonian physics is true. And anybody who comes in with this new theory of relativity and doesn't have a bunch of data points to present on day one, why should I listen to them? I'm so confident. So you could get really confident about Newtonian mechanics. And if somebody came along and said, you can push something arbitrarily hard and it's never going to go faster than this particular speed limit, the speed of light, they might be like, what are you talking about? A speed limit? Everything's linear. I understand Newtonian mechanics. Where are you getting this? So it's also possible for data points to just drive you off a cliff in terms of making you too far convinced. And once again, the takeaway is just we can't do epistemology based on extrapolating graphs. We have to use a more fundamental version of forming hypotheses, noting how those hypotheses compress data and giving them probabilities accordingly and just doing Bayes. Like, this framework is called Bayes. I'm sorry that I have to explain the first principles of Bayes because people like refuse to get it and just kind of make ad hoc arguments without understanding Bayesian reasoning. Just one more response I wanted to give to the piece as a whole. What's the alternative to reasoning with probabilities? If I don't say, hey, I feel like there's a 50% chance of doom, I feel like there's a 10 to 90% chance of doom, if I just don't say that, what am I supposed to do instead? How am I supposed to recommend policies without quantifying some giant ballpark estimate of doom? In practice, what happens when people don't use probabilities is just that they use English words to accomplish the same thing. So the English word significant chance of extinction is now just substituting for a range like, hey, I feel like 10 to 90%. It's the same thing. It's just that the number is a little bit better because the number doesn't require everybody to implicitly translate the number in order to make policy. Like, now I don't have to clarify, by significant, do I mean more than 1%? Why, yes, in fact, I do. I mean 10 to 90%. So the number actually is conveying information. They do not spell out an alternative way to reason or conduct policy. All they do is basically throw shade on the idea of using a probability. And it's just like, it's just not even specific to this particular debate, right? It's just this epistemology level debate of like, oh my God, are Bayesian probabilities meaningful? And the most recent piece of evidence that gave the answer a simple yes is if you just go on manifold markets, manifold.markets, or you go on Polymarket, you just look at modern prediction markets, they have an incredible track record. There's actually a study that shows that their calibration is near perfect. So even though they predict all kinds of things, all kinds of events that don't have inductive or deductive models, to use Sayash's language, even then, their calibration is somehow near perfect. So apparently, we as humans can somehow give calibrated probabilities. And you don't understand how, but it's just an empirical fact that we can. So why don't you inductively extrapolate the empirical fact that probabilities are working really well on these prediction markets and extrapolate that to concluding, hey, maybe when doomers say 10 to 90%, then we should make policy as if the probability is 10 to 90%, as opposed to like ignoring that and using some alternate framework that I haven't specified. Okay, I think that's all I have to say about that. I will add that overall, listening to Sayash's podcast, I like him. I think he came off as very smart and informed, just not on this particular topic. The topic on this post, where he titled it AI Existential Risk Probabilities Are Too Unreliable to Inform Policy, I think he's way off base. And while his points do make sense, like I get where he's coming from, I think he totally lost the plot in this particular post. So I would encourage him to really reconsider whether he's talking any sense in this post, but I do like a lot of his other points and I like him in general, and I hope that I can come back on this podcast and say how something else he wrote is actually awesome. That's all for me, but if you want further reading, I highly recommend a post by Scott Alexander from March of this year called In Continued Defense of Non-Frequentist Probabilities. Highly, highly recommended post. I hope Sayash checks it out because it contradicts a lot of what he's saying. Besides that, if you believe in the Doom Debate's mission of moving the Overton window so that the larger population realizes AI doom is real, it's urgent, the arguments for it are strong, the people who are acting like it's going to be okay don't know what they're talking about. If you support the mission of building shared common knowledge about that, then it's pretty easy to help the podcast out. Just share it in whatever forum you're posting on, share it on social media, tell a friend about it, and then make sure you yourself are subscribed at youtube.com/@doomdebates, doomdebates.com for the Substack subscription, twitter.com/Liron, and also your podcast player, search Doom Debates. Also, bonus favor, go to Apple Podcasts, search Doom Debates, leave a positive review there. That also helps a lot. Thank you, appreciate it. And I'll see you next time here on Doom Debates.